In this lesson, we're going to talk a little bit about conic hyperbolas. What happens is we've been looking at this generalized standard form second-degree polynomial function over and over and over. We talked about what happens when how you have an x value, x squared, or a y squared. That was your parabola. If you had an x squared and a y squared, you had your ellipse. Well, if you have an x squared and a y squared, and if one of them is negative, then you're going to get a conic hyperbola. Now, a conic hyperbola is different from the hyperbolas you've studied before. For instance, you have this guy right here, which was the graph of x equals 1 over x, or also known as y equals 1 over x. And you had a vertical asymptote here because x equals 0 is undefined. You had a horizontal asymptote here because no matter what you put in for x, you never got an output of 0. So the asymptotes will remain in the conic hyperbolas, but we will take a little bit different of an approach because they're going to be oriented not quite in this same manner, but vertically. In other words, you're going to have hyperbolas looking like this vertically, where your asymptotes are going to be kind of slanted, and you're going to also have horizontal hyperbolas that kind of look like this. So again, slightly different perspective because we are dealing with a slightly different set of equations, but we're going to take a very similar look into hyperbolas as we have for parabolas and ellipses, in that we want to graph them by finding all their parts, or take their parts and write equations. So very similar look. So let's just dive right in. First of all, as I alluded to in the previous frame, you're going to have a couple of different types of hyperbolas. The horizontal hyperbola is named, given that what's called the transverse axis, which is the blue one here, is a horizontal line. The transverse axis goes through the center and through the vertex and focus. Perpendicular to the transverse axis is what you have called the conjugate axis. Basically, you kind of have a little rectangle in the center here. But you see you have some slanted asymptotes in this case as well. So now you look at the vertical hyperbola over here. You have a vertical transverse axis. Again, the transverse axis passing through the center, the vertices, and the foci. Perpendicular is the conjugate axis. Truth be told, we're not going to really do much of anything with the conjugate axis. It's just one of those. They exist, again, to graph them. We're not really going to do much with it. Okay, so onward and upwards, let's take a look at the equations of hyperbolas. So here is the equation of a horizontal hyperbola. Notice you have an x squared term and a y squared term, but you have a negative in between them. You still have a h and k to determine the center. You still have an a value, which is going to help us find the vertices. So once again, the distance from the center to the vertex is a. You still have a c value that needs to be calculated to find the foci. The distance from the center to one of the foci is that c value. The formula, quote unquote, for c is a little bit different in this case. It is a squared plus b squared. Essentially, it is the Pythagorean theorem. So just keep that in mind as you go. The vertices and asymptotes, like I said, the formula should look pretty familiar. Now you also have a pair of formulas for finding the asymptotes. Basically, you have this k value from your vertex, from your center. Plus and minus, you got b over a as a coefficient of the x minus h term. What's going to happen is these are both going to be linear equations. You split them up, make two of them, you'll graph them, and they'll be the boundaries of your hyperbola. So that's how horizontal hyperbolas work. And last but not least, you have your vertical hyperbolas. Similar trend. You have, in this case, y squared first, minus x squared. One big thing to note is the difference in the a's and b's. The a is always under the first term, where the first term is positive. In ellipses, A was larger than B, and that helped us determine whether it was horizontal or vertical. That is not the case with hyperbolas. Okay? So once again, in ellipses, A was bigger than B. That is not the case with hyperbolas. A is under the first or the positive term. B is under the second or the negative term. A is under the first or negative or positive term. B is under the second term or the negative term. So the first term, the positive term, determines if it's the y that's first, it's vertical. If it's the x is first, it's horizontal. And then once you determine which set of formulas you'll use, go ahead and calculate centers, vertices, foci, all that good stuff. The only thing that should be new about this process is likely finding the asymptotes. So we will definitely spend some time talking about that. So that's the important feature here. But once again, just to reiterate, the distance from the center to the focus is C. I realize that I wrote right over that. So that's your C value. And then the distance from the center to the vertex, that's your A value. Okay, so as I said, in the next couple of videos, you'll see actually graphing these guys and writing the equations. But this one was just an overview to the actual equations. By now, I hope this should be pretty straightforward. It still will require a great deal of precision and taking your time, but hopefully by now you're getting a little more comfortable with the idea of conic sections.